What do waste and contaminated water have in common? Well, we can think of a couple things. They're both problems, and they're both have been getting more and more attention recently due to pollution and climate change. But there's one thing in common that might surprise you: a solution. There are issues that they can both be tackled with a process called pyrolysis. Pyrolysis is a process where you take a material, which can be waste, plastic, food, and you put it into a closed space, a reactor. You raise the temperature, and you do this in the absence of oxygen, which prevents the material from burning up. So pyrolysis obtains three products: a solid, a liquid, and a gas product, all with different applications and value. The solid product, also called char, is the main focus of my research, and is this black porous material, powdery, and it can be used in many, many applications, from your backyard barbecue as the familiar charcoal, or to agricultural applications, and many others. And due to some special properties it has, it can be used to remove contaminants from air and water in a process called adsorption. To use char to remove contaminants from water, it usually goes through a secondary process called activation, where it's transformed into activated carbon. This process is usually, exposes the material to high temperature and an activating agent, which is usually steam or CO2. Activated carbon production is a very time and resource consuming process, and so my research aims to produce a solid product that can remove contaminants from water, but in a continuous, one-step manner, more sustainable, and using wheat straw, which is kind of an agricultural waste and available everywhere. So far, I've seen that even using char from pyrolysis alone, I can remove up to 90% of the dye I'm using, and then I plan to increase this value so it can become competitive with commercial activated carbons. The way my adsorption experiments work is that I take the solid material I produce, I mix it with water that has a dye dissolved in it, and the dye makes the water have this dark blue color. After some mixing time, the blue becomes lighter, and the water can even become clear, which means the dye is being removed. And I can measure the amount of dye that remains with a spectroscopy technique that uses UV and visible light. So with activating the material I'm using by integrating activation procedure with the pyrolysis procedure, I plan to increase the adsorption performance of the material, and hopefully with pyrolysis and char I can tackle both the waste accumulation problem and the water pollution problem. Thank you.